Hello, this is Ed Harmouche for PracticalNetworking.net. In this lesson, I'm going to teach you about wildcard masks. Before you watch this video, there's a couple things you must understand. First, you must understand subnetting. If you're not intimately familiar with subnetting, go and check out the Subnetting Mastery video series. There's a link in the description, or you can access all the videos at subnetipv4.com for free. The other thing you must understand is binary. In this video, we'll be doing some binary conversions, but we're not going to explain how. If you want to learn how to convert and count in binary, go and check out the binary video we just released. There'll be a link in the description. That said, if you understand these two things, we can start talking about wildcard masks. A wildcard mask is very similar to a subnet mask, except that the ones and the zeros are flipped. So let's talk about that. Here is the Saturn notation of a /26. This 26 refers to the fact that the subnet mask in binary has 26 ones. Now if we convert each of those octets into decimal, we would get the correlating subnet mask for the /26 of 255.255.255.192. A wildcard mask is the same thing, except wherever there is a 1, there'll be a 0, and wherever there's a 0, there'll be a 1, which would give you something that looks like this. And again, if we translate each of those octets into their decimal counterpoints, for these 3 octets, we would have the decimal value of 0, and then for this guy, we would have the decimal value of 63. That's all a wildcard mask is. Let's go ahead and show you another one. Here is the Saturn notation of /21, which means the subnet mask has 21 ones in binary. If you convert each of those octets into decimal, you would get that this /21 insider correlates to the subnet mask of 255.255.248.0. The wildcard mask, again, would simply have all these ones flipped to zeros and all these zeros flipped to ones, giving us a wildcard mask that looks like this. And if we convert each of those octets back into decimal, we would get a wildcard mask of 0.0.7.255. So the Saturn notation of /21 correlates to the subnet mask of 255.255.248.0, which correlates to the wildcard mask of 0.0.7.255. Now let's do a couple more, but these two are going to be special. This is a /32. You and I know a /32 as an indication of a single IP address. The correlating subnet mask for a /32 is 255.255.255.255, which would make the correlating wildcard mask for a /32 0.0.0.0. So if you ever see the wildcard mask of all zeros, know that you are referring to a single IP address. This is a /0. You and I know that a /0 is a reference to every IP address in the IPv4 internet. The correlating subnet mask for a /0 is 0.0.0.0. Therefore, the correlating wildcard mask would be 255.255.255.255. So if you ever see the wildcard mask of 255.255.255.255, know that you are referring to every IP address in the IPv4 internet. So you'll always be able to convert between wildcard mask and subnet mask by taking the binary of the subnet mask, flipping all the bits, and converting it back into decimal. But there's also an easier way to do the conversions. That easier way involves simply subtracting each octet from 255. For example, this is the /21 that we converted earlier using binary. A simpler way to have converted it from subnet mask to wildcard mask would simply be to subtract each octet from 255. So 255 minus 255, that's 0. 255 minus 255, that's also 0. 255 minus 248, that gets you 7. And 255 minus 0, that gets you 255. Let's do another one. Here is another subnet mask. Let's convert this to a wildcard mask using this subtraction from 255 trick. Well, 255 minus 255, that's going to be 0. 255, 255, that's going to be 0. This is going to be the same thing, 0. And then 255 minus 224, that's going to be 31, which means the subnet mask of 255.255.255.224 correlates to the wildcard mask of 0.0.0.31, which correlates to the Saturn notation of /27. Here's another one. Now I want you to do this one yourself. Go ahead and pause this video and use this subtraction from 255 trick to convert this subnet mask to a wildcard mask. I'll give you the answer in 3 seconds. If you subtract 255 from 255, that'll get you 0. It'll be the same for the second octet. If you subtract 240 from 255, that would get you 15. And if you subtract 0 from 255, that would get you 255, meaning that the subnet mask of 255.255.240.0 correlates to the wildcard mask of 0.0.15.255, which correlates to the CIDR notation of /20. Now, the cool thing about the subtraction from 255 trick is that it works in either direction. If we had this wildcard mask and we were trying to convert it into a subnet mask, we could again simply subtract each octet from 255. 255 minus 0 is 255. 255 minus 0 is 255. 255 minus 7 is 248. And 255 minus 255 is 0. So this trick works in either direction, if you're going from subnet mask to wildcard mask or wildcard mask to subnet mask. So that's a high-level overview of what wildcard masks are. It's simply a subnet mask, except the ones and zeros are flipped. In fact, wildcard masks are sometimes referred to as an inverse subnet mask, because they're sort of like a subnet mask, just the opposite. But what can you do with wildcard masks? Great question. Wildcard masks provide 3 functions. The first function is you can use a wildcard mask to determine if 2 IP addresses are in the same subnet. The second function is you can use wildcard mask to identify the IP addresses in a particular subnet. And the third function we'll explain in a moment. I want to start by talking through these 2 functions. Now, both of those first 2 functions can also be done with a subnet mask. So if you already understand subnetting, which at this point I'm hoping you already do, the skill of how to do these 2 things with a wildcard mask is something you already know. So let me go ahead and show you how it's done with a wildcard mask. Starting with that first one. Let's use a wildcard mask to determine if 2 IP addresses are in the same subnet. Here are 2 IP addresses, 192.168.1.125 and 192.168.1.135. If we translate both of those IP addresses into binary, we would get something that looks like this. If we wanted to see if both of these IP addresses were in the same subnet, we would need a subnet mask or a CIDR notation. You and I know how to translate subnet masks into wildcard masks, and if we translated this subnet mask into a wildcard mask, we'd end up with something that looks like this. Now, to see if these 2 IP addresses are in the same subnet, if we're using a subnet mask, all we're going to do is look to see if we have matches in every column where there's a 1. So we would simply identify wherever there is a 1 in the subnet mask, and we would look for a match in all of those columns in the IP addresses we are comparing. You'll see that we don't have a match in every single one of these columns, and this tells us that these 2 IP addresses are not in the same subnet. We can do the same thing with a wildcard mask, except with a wildcard mask, we're going to be matching on zeros. And just like we did a second ago, we'll simply look in every area where there's a 0 in the wildcard mask, and if we have a match across all of those bits, then we know the IP addresses are in the same subnet. In this case, we don't have a match, therefore the wildcard mask can also tell us that these 2 IP addresses are not in the same subnet. So let's change our IP addresses a bit. Let's change them to .130 and .160 and run the same test. We'll start with the wildcard mask. Let's look across all the zeros and see if we have a match across each of our zeros. With these 2 IP addresses, it appears that we do have a match across all of those bits, which tells us these 2 IP addresses are indeed in the same subnet. We could have again done the exact same thing with a subnet mask by comparing the ones. One way or another, the process is the same. You can use a subnet mask or a wildcard mask to determine if 2 IP addresses are in the same subnet. So that takes care of the first function of wildcard masks. Let's now talk about the second function of wildcard masks, is that you can use a wildcard mask to identify the IP addresses in a particular subnet. All you have to do is combine a wildcard mask with a network ID. Now, you can actually do the exact same thing with a subnet mask or even CIDR notation. For example, this is a /24 network. If I wanted to refer to the specific 256 IP addresses in that /24 network, I would pair the network ID of 9.9.9.0, which is the first IP address in this block, and either the CIDR of /24 or the subnet mask of 255.255.255.0 or the correlating wildcard mask of 0.0.0.255. Now, of course, subnetting is about taking one subnet and breaking it up into smaller subnets, and I can refer to any of these subnets using either of these tools. For example, if I wanted to refer to this block of /28 addresses, I would simply pair the network ID of 9.9.9.32 with either the CIDR of /28 or the subnet mask of 255.255.255.240 or the correlating wildcard mask of 0.0.0.15. This network ID with either of these things is going to refer to this particular chunk of 32 IP addresses. If I want to refer to that particular /26, again, I would simply pair the network ID of 9.9.9.64 with either that CIDR or that subnet mask or that wildcard mask. And if I wanted to refer to this particular chunk of /27s, again, I would pair that network ID with that CIDR or that subnet mask or that wildcard mask. Do keep in mind that the network ID itself is not enough to refer to a specific block of addresses. You must pair the network ID with one of these three things. In our example, a network ID of 9.9.9.64, which is the IP address that would exist right here, paired with the CIDR of /26 or the subnet mask that ends in 192 or the wildcard mask of 0.0.0.63 refers to this chunk of 64 addresses. Whereas if you paired it with the CIDR, subnet mask, or wildcard mask down below, you'd only be referring to this chunk of 32 addresses. Either way, this shows us that second function of wildcard masks, that you can use a wildcard mask to identify a particular subnet. So at this point, we've covered the first two functions of wildcard masks. But in particular, we also covered how you can do the exact same thing with a subnet mask. So you might be asking yourself, what's the purpose of a wildcard mask if you can do everything we've talked about so far with a subnet mask? That's a great question. And the answer has to do with this third function. The third function of a wildcard mask is that a wildcard mask will let you identify IP addresses which are discontiguous, which is to say, IP addresses that are not grouped sequentially. So let's talk about it. By rule, subnet masks are a series of ones followed by a series of zeros, which means they look something like this. So far, all the wildcard masks we've looked at have been a series of zeros followed by a series of ones. So they've looked like this. But they don't have to be. This right here is a perfectly valid wildcard mask. You can have alternating sets of zeros and ones as necessary in your wildcard mask. This is what's known as a discontiguous wildcard mask. Either way, what we learned about wildcard masks still applies. A wildcard mask will still simply look for a zero, but it'll look for a zero wherever they appear. It doesn't have to be just at the beginning. And I'm going to show you exactly how discontiguous wildcard masks work in another video. For now, I simply wanted to define what it is and to show you how it was different from subnet masks. So that wraps up this lesson on wildcard masks. To summarize, we talked about a few things in this lesson. First, we talked about how to convert between subnet masks and wildcard masks. Then, we went into a discussion of the three functions of wildcard masks. We talked about how wildcard masks allow you to determine if two IP addresses are in the same subnet, and wildcard masks can also help you identify IP addresses in a particular subnet. We mentioned that these two things can also be done with regular subnet masks and regular CIDR notation. The thing that is unique to wildcard masks, however, is this third one, which are wildcard masks allow you to identify IP addresses which are discontiguous, and the ins and outs of how that works will be the focus of another video. I hope you enjoyed this video. If you did, please consider liking and subscribing. Otherwise, I want to thank you for watching, and I'll see you in the next video.